so this is where we left off on Friday. And if you'll remember on Friday, instead of calling those sides opposite adjacent hypotenuse, we were using the X, Y, and R concept. And that's the little stuff written on the board over there, and you also put it on your formula sheets. So those who were not here, be sure that you catch up on that. Okay, so thinking of what we talked about here, back on page 2 of the notes, how we used X, Y, and R with that right triangle that was inside that circle. Think about ordered pairs, X and Y, in the first quadrant. What kind of signs do we have? SIGNs. Like positive and negative. Both are positive, aren't they? So I have a positive X and a positive Y value in the first quadrant. Okay, in the second quadrant, what kind of SIGNs do I have? Negative X, positive Y. Okay, third quadrant. Negative X, negative Y. And to me, that always looks like a little sleeping owl. Does it not? Now you can't unsee that, can you? Because every time I write that, I think little sleeping owl. Okay, what is this one? Positive X, negative Y. Okay, so if sine is Y over R, and remember we said on Friday that R is always positive. Because it's technically representing the radius of a circle. So R is always positive, X is positive sometimes, Y is positive sometimes. Those two things depend on which quadrant you're in. And this is where X is positive, X is negative, Y is positive, Y is negative, what we just wrote over here. But R is always positive. Okay, so if sine is Y over R, in which quadrant is sine positive? In which quadrant would the function sine be positive if sine is Y over R? What am I asking you? If I took a Y value from the first quadrant, which is always positive, and put it over R, would I get a positive number? Yes. Okay, I'm going to write this, don't write this down yet. I'm going to write sine in pencil there. And then I'll come back and do them in pen and you can write those down. Okay, if sine is Y over R in second quadrant, would sine be positive? Yes. Would sine be positive here? No, it'd be negative because the Y's are negative. Would sine be positive here? No, because Y's are negative. Okay, we're going to go through and do the same thing with cosine. Cosine is X over R. So if I took these X coordinates and put them over R, which is always positive, would that be positive? Yes, it'd be a positive over a positive. Okay, would cosine be positive here? No, because the X's are negative. Would cosine be negative here? No. Would cosine be negative or positive here? Which one? Positive. Okay, let's go through tangent. Would tangent be positive here? Remember, tangent is Y divided by X. Yes. Would tangent be positive here? No, because it'd be a positive over a negative. Would it be positive here? Yes, because it'd be a negative over a negative, which would give me a positive tangent. And would tangent be positive in the fourth quadrant? No. Negative over a positive is a negative. Okay, so I wrote down the words of the things that are positive in each quadrant. Everything is positive in the first quadrant. Only sine, only tangent, only cosine. Now what about their reciprocals? Like what about cosecant? It's going to be the same as sine. Cotangent will be the same as tangent. Secant will be the same as cosine. So I only have these three written down, but their reciprocals are the same. Okay? Alright, so this is kind of a little, I don't know if it's a trick, but it's a summary of what we just talked about. What's positive in each quadrant? All are positive here. Everything is positive. sine, cosine, tangent, and their reciprocals. Okay, what's positive in the second quadrant? Only sine and its reciprocal. What's positive in the third? Only tangent and reciprocal. What's positive in the fourth quadrant? Only cosine and its reciprocal. Okay, oh, and I forgot that I already put that down there too, so that's worth mentioning again. Okay, so there's this little thing that we say sometimes, all students take calculus. All students take calculus. As a little reminder of what's positive in each quadrant. Does that make sense? Okay, so ASTC, all students take calculus. Okay, so we're going to use this, and this would probably be something that I'll stop in a second and let you put on your formula sheet, because this is important. Okay, here we go. Example 6. Find cosine theta and tangent theta for the angle where sine theta is 3/7 and tangent theta is less than 0. Say what? Okay. All this information right here is going to tell us which quadrant we're in. So it's like we've been given clues. I'm giving you 2 clues so that you can figure out which quadrant this angle is in. Okay, so sine is 3/7. That's a positive number. Where is sine positive? Sine is only positive in these 2 quadrants. So already I've eliminated 2 quadrants. It can't be quadrant 3 or 4. And tangent is less than 0. If something's less than 0, what is it? It's negative. So this is saying tangent is negative. Okay, well, sine is positive in these 2. Of these 2, which one has negative tangent values? 2, because everything's positive here. So all of that is my clue or my hint that I'm in quadrant 2. Who has a question on that? Okay. All right, so once you figure out your quadrant, then we're going to draw a picture. So I'm going to be in quadrant 2. Sine is 3/7. Well, sine is opposite over hypotenuse. So I'm going to label a triangle. Remember the rules that I told you on Friday. The right angle is always with the x-axis. Theta is always the acute angle up by the origin. So that's the triangle that we're using. Now, label what we were given. Opposite is 3 and hypotenuse is 7. So it's a lot of cryptic information in there. So you've got to decipher it all, figure out, first of all, which quadrant you're in, then how to label the triangle. Okay, so if I want cosine and tangent, cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So I've got to find those 2 ratios and then I'm done. Okay, well, I don't know adjacent. And I need adjacent in both of them. How am I going to find adjacent? Pythagorean theorem. Okay, so I'll call that x because that's really going to represent an x coordinate. And so I'm going to say x squared plus 3 squared. You can use a squared, b squared. And make sure you're getting the hypotenuse of 7 as your c squared value. So x squared plus 9 equals 49. We can do this in our head. 49 minus 9 is square root of 40 is, has a factor of 4. What's the square root of 4? So I get 2 square root of 10. But should I label this with a positive or a negative? Why would I label it with a negative? Remember how on Friday, if we went left or down, we used a negative to indicate that direction. So because I'm going left of the origin, that's where negative numbers are. So I'm going to use a negative. I went up, so it's a positive. Anytime I go left or down, which is considered a negative direction, then I will use negatives. R, the hypotenuse, is always positive. Okay, now I can plug in these values. So I have adjacent over hypotenuse. Radicals on top, nothing reduces, we're done. Tangent is opposite over adjacent. Okay, if I rationalize that, what do I multiply by? I only have to multiply by the radical. So square root of 10 over square root of 10, you can check it on your calculator as well. This will give me 3 square root 10 over negative 2 times 10, negative 20. And I would personally prefer to put that negative out front so I don't miss it. Did not see it in the bottom. Who has a question? That's a lot of stuff in that little problem. You could. So if I did a negative and a negative, then it would move the negative here, but in the bottom would become positive. And I would still only have one negative. So yes, that's a perfect legitimate option. Any other questions? And then I thought someone might say, can you multiply by negative 2 square root of 10 top and bottom? Yes. You'll just have a fraction that will have to be reduced, and then you will end up with this fraction. Okay? All right, any questions? Okay, let's tackle the next one. Okay, so remember, it's like cryptic information. We have to figure out, first of all, which quadrant are we in, and then we'll sketch a picture. Find sine, so I'm only looking for one little thing, for the angle where secant is 3 and sine is greater than 0. Okay, I'd like to think of 3 as a fraction, first of all, so that will be 3 over 1. Okay, secant is the reciprocal of what? You said it right? Oh, I thought you said it. Cosine. Secant and cosine go together. So if secant is positive, that means that cosine is positive. Because they're reciprocals. Cosine is going to be 1 over 3. Still positive. And then if sine is greater than 0, what does that mean? If a number's greater than 0, it is positive. So this tells me sine is positive. Okay, so let's use this information. Where is cosine positive and sine positive? Which quadrant does that happen in? Quadrant 1. That's where everything is positive. Only sine is positive here. Only cosine is positive here. First quadrant is the only place they're both positive. Okay, so this tells me I'm in quadrant 1. Okay, so now we're going to draw a picture. Focus our triangle on quadrant 1. Okay, so every single time we're coming out of the origin, perpendicular to x, theta is up by the origin. And then label what you were given. So secant is whatever what. Or let's start with cosine. Cosine is whatever what. Adjacent over hypotenuse. So this is hypotenuse over adjacent. Okay, so I'm going to label hypotenuse 3, adjacent 1, and I'm looking for sine. Sine theta is opposite over hypotenuse, so I've got to figure out what opposite is. I'm going to use the Pythagorean theorem. Has anyone already done that? What'd you get? 2 square roots of 2. You should get square root of 8, which reduces. Do I need to make this negative? No, because I went up. I'm in the first quadrant, X and Y are both positive. Okay, so now I can figure out what opposite over hypotenuse is. Opposite theta is 2 square root of 2. Hypotenuse is 3. We are done. Bad? Good? Okay. 3 more, and then we'll spend the rest of the time working on homework. How's that sound? We'll watch the video. Okay, find all trig functions of 315 degrees. Draw a picture. You will have to use ratios for a 45, 45, 90 triangle. Okay, I'll explain this little part in a minute. If I rotate 315, which quadrant am I in? 315 degrees. Remember, we start here, and if it's a positive angle, which way does it circulate, rotate? Counterclockwise. So if I go counterclockwise 315, I end up in which quadrant? 4. Quadrant 4. Okay, so I have rotated 315 degrees. Okay, well, what we're going to use is what we've been using. We call this a reference triangle. So I take this ray that rotated, and I'm going to go perpendicular to the x-axis, and I'm going to use this little angle here so that I can have a right triangle. Now, how much is theta if I rotated 315? How would I find it? How would I find that angle theta? 360 minus 315 is what, Charles? You just typed it in. 45. Okay, so it's the rest of the circle after I rotate 315, so it's 360 minus 315, which gives me 45. Okay, so if this is perpendicular and this is 45, what does this have to be? 45. Now, I didn't give you any triangle lengths like I did on the last one, so that's when we're going to use those ratios that we know. It doesn't matter what the lengths are, the ratios will be the same. So I'm going to use 1 square root of 2, but I'm going to make this one a negative 1. Why? To indicate direction. I went down 1. I went right 1. I went down 1. So I'm going to label that as a negative. Because in the fourth quadrant, y coordinates are negative. Okay, so now I'm just using those ratios. And I went all 6 trig functions of 315. So I'm going to use this reference triangle, is what we call it, to find sine of 315. Cosecant, cosine, secant, all the rest of them. Okay, so sine is what over what? Haley Bit. Yes, ma'am. Opposite over hypotenuse. Negative 1 over square root of 2. But if we rationalize that, we get negative square root of 2 over square root of 4, which is just 2. Okay, cosecant is the reciprocal of this. I don't want to take the reciprocal of that because I'd have to rationalize again. So I'm going to go back to that first fraction. Hypotenuse over opposite. And let's just make that negative square root of 2. Okay, cosine is adjacent over hypotenuse. Isn't it going to be the same fraction, but it'll be positive, won't it? So it's going to be 1 over square root of 2, adjacent over hypotenuse. Rationalizing that, I will get square root of 2 over 2. secant is the reciprocal of cosine, so it's going to be square root of 2 over 1, which is just square root of 2. Okay, I'm going to have to come over here. Tangent is opposite over adjacent. Negative 1 over 1 is negative 1. And then cotangent is adjacent over opposite, which is also just negative 1. There's a question. Come on, these are fun, don't you think? Well, some of you think so. All right, example 9. Find the following without using a calculator. You will need to use special triangle ratios, sketch a picture. Okay, negative 210. If I rotate negative 210 degrees, that means I'm going clockwise 210. Where do I stop? Lanier, did you do 3, 4, and then 2? Okay, so not 1? Okay. 2? What do y'all think? 2? Okay. So if I go clockwise, this would be 90, 180, 270. So I don't need to go that far. So yes, it's definitely somewhere in here. Okay, if this was 210 degrees, my triangle that I want to form is always, always, always perpendicular to the x-axis, and I'm going to use this little reference angle theta that is up by the origin. How much is theta? $30. And how'd you find that? Exactly. So he realized, like, okay, I went a little more than 180. So how much more did we go? 210 minus 180 gives us 30 degrees extra. So we went 30 degrees beyond 180. Yes? If you did 270 minus 210, then what you found was this angle here, and then you'd have to find its complement by subtracting from 90. Do you see what I'm saying? Okay. So yes, you could get there as long as you knew that you were finding this angle and then use it to find this one. Any other questions on finding that angle? Okay, well guess what? I don't have any measurements like I gave you before. So we have to rely on this 30, 60, 90 ratios. Okay, so the ratios are, this is 60 up here. Opposite 30 is what? Opposite 30 is what length? Opposite 30 is what length? 1. Look over here on this triangle. My 30 is up here. So opposite 30 is 1. Opposite 60 is square root of 3. Hypotenuse is 2. Okay, so it's always 1 is the shortest side. Opposite the 30. Opposite 60 is square root of 3. Hypotenuse is 2. Now, I have to make one adjustment. Negative square root of 3 because we went left. X's are negative over here, so we went left, which is negative, up, which is positive. Hypotenuse, which also represents the radius of circle, is always positive. So the only things you have to adjust for are the legs. The left and the right, the up and the down. Check to see if you need any negatives. Okay, so now I need sine of 210. I'm going to use this reference angle for my 210. Sine is opposite over hypotenuse. Whew, no work to do on that one. Okay, and if I were to check that, and just doing it on your calculator will not be enough on the quiz, I will need to see the picture. I will need to see the sides labeled. But can you check your answer from here? Absolutely. I'm going to make sure I'm in degree mode. And I'm going to type in sine of negative 210. And I get 1/2. Okay? So you can check it on your calculator, but this is what I will need to see on your paper. Okay? But at least it'll let you know if you're right or not. Okay, so next one, same thing. Tangent of 5 pi over 3. Okay, so if we're not real used to radians yet, remember what I told you, pi equals how many degrees? 180. What is 180 divided by 3? What is 60 times 5? It's 300 degrees. Okay, or how do I convert? I take 5 pi over 3 and multiply by 180 over pi. Pi's cancel. Simplify that, we should get 300. Okay, what I did with you was just a little mental shortcut. Okay, so I need to know opposite over adjacent eventually, but I don't even have a triangle. If I rotate 300 degrees, which quadrant do I end up in? Start on the positive x-axis. It's a positive angle, so we're going counterclockwise. 300 degrees would put me in the 4th quadrant. So that is 300. Okay, but I'm going to use this thing that we call a reference triangle, and I'm going to go from that ray perpendicular to the x-axis and use this little reference angle theta that is up by the origin. How much is theta? 60, because it's 360 minus 300, so this is a 60 degree angle. Well, that forces this one to be a 30, because they have to all add up to 180, right? These two have to be complementary, add up to 90. Okay, so I'm back to my 30, 60, 90 ratios. Opposite 30 is what? Opposite 30 is 1. Opposite 60 is square root of 3, but I am going to use a negative. Good job, because I went down, and the hypotenuse is 2. So it's the same ratios I used over here. I just had to make the adjustments for what was opposite each side. Okay? So now I need tangent. Tangent is opposite over adjacent. So I'm going to use this triangle and do opposite over adjacent, negative square root of 3 over 1, which is just negative square root of 3. Question. There's like all these different ways to ask the same thing. So it's different combinations of information that you have to interpret and manipulate. Okay, find each. If it exists, sketch a picture. All right, negative 210. Negative 270. If I rotate negative, that means clockwise. So if I start on the positive x-axis and I go clockwise 270, where am I? Positive y-axis, 270 degrees in a clockwise direction. If I'm here, can I make a right triangle back down to the x-axis? No. Okay, so this is a little different. Ooh, do you remember what this angle is called if it lands on an axis? Starts with a Q. And it's kind of a funny name because it's not in what the root word is. Quadrantal. It's a quadrantal angle because it doesn't land in a quadrant. It's on an axis. Okay, so I can't draw a right triangle. So what we do, pick any point on this axis. Pick any point you want. Someone tell me the order pair you chose. Label it. Okay, someone tell me what you used. John, what you used? 0, 3. Okay. 0, 5? 0, 5 also? Anybody use 0, 1? It doesn't matter. Whatever we use. Okay, so the first one I heard was 0, 3. I'll use that one. If I drew, I should almost have a circle through it. If I made a circle through that point, what would the radius be? How far is that point from the origin? 3. Now, if you chose the order pair 0, 5, what would your radius be? 5. If I used 0, 1, my radius would be 1. Okay, so I'm going to have r equals 3. Okay, so since I don't have opposite, adjacent, and hypotenuse, guess what I have to use? X, y, and r. That's what I have to rely on. So if I want to find sine, sine is y over r. Y over r. What's my y coordinate? 3. What's my r? 3. Okay, so if Charles had 5, he would have 5 over 5, and guess what? We all get the same answer of 1. Okay, tangent's 3 pi. All right, let's not convert this one. How much is 1 pi? 180. Okay, so what if I went 1 pi, 2 pi, 3 pi? Wouldn't I be back over here? I mean, you can do the conversion if you want, but just think of it as 3 separate 180s. So once, twice, 3 times puts me back over here. Okay, so again, I can't draw a right triangle with the x-axis. I'm on the x-axis. So again, we're going to do the same thing. We're going to pick a point out there. Any point you want. I'm going to use negative 10, 0. If I drew a circle through that point, what would the radius be? 10. Even though this point is left, the radius of a circle would be just positive 10. So there's my x, y, and r value. Okay, let's go back and look at tangent. Tangent is y over x. Y over x. My y is 0. So is yours if you used a different point. And my x doesn't really matter because what is 0 divided by a number? 0. One more. 11 pi over 2. Okay? Pi is 180. So what's 180 divided by 2? It's half of 180. 90. What's 90 times 11? What's 9 times 11? 990. This is the same as secant 990 degrees. Oh my goodness, that's more than once around the circle, isn't it? Okay, let's use that concept of coterminal. I'm going to subtract 360. It's the same place as 630. That's still more than one time around. So I'm going to subtract another circle. Oh, it's the same place as 270. I know where that is. That's down here on the negative y-axis. So counterclockwise 270 puts me down here. Again, I can't draw a right triangle to the x-axis because I'm already perpendicular. So I'm going to pick a point. Any point. Someone give me a good one to use. 0, negative 4. Okay. If I drew a circle through that point, what would the radius be? Just 4. Okay, it's secant. So I'm going to go back. I'm going to look up secant. Secant is r over x. R over x. Okay, so that's radius of 4, x is 0. What is that? undefined. And no matter what x value you used, 0 would be in your denominator also, so we would all get undefined. That's a lot of information, isn't it?
Yep.
Think we got it absorbed? I think we need to work on the homework, don't you? Okay, so get your assignments. You should be able to tackle all of it now. It will be due tomorrow, but you have about 40 minutes, it's almost 45, to work on it.